Have you ever wondered what happens when the sun throws a tantrum? Imagine a celestial ballet, a dance of energy and magnetism on a cosmic scale. This is a solar storm, a spectacular eruption of energy from our very own star, the sun. It all begins deep within the sun's core, where intense heat and pressure generate a magnetic field. However, this magnetic field isn't as stable as it might seem. Sometimes it can twist and snap like a rubber band stretched too far, releasing massive amounts of energy into space. This energy manifests as solar flares and coronal mass ejections, two of the most powerful phenomena in our solar system. These solar flares, akin to the sun's fiery breath, are bursts of light and energy that can reach temperatures of millions of degrees. Coronal mass ejections, on the other hand, are enormous bubbles of gas and magnetic fields that rocket into space at high speeds. These solar outbursts can have a profound impact on our planet, but how? From the heart of the sun to the confines of Earth, a solar storm embarks on a journey spanning millions of miles. It all starts with a violent eruption on the sun's surface, known as a solar flare. This flare, a veritable explosion of electromagnetic energy, catapults a burst of charged particles into space, creating what we call a solar storm. This storm, or more technically a coronal mass ejection, is hurtled outwards at a breathtaking pace. The speed of these storms is truly staggering, with some reaching velocities of up to a few million miles per hour. However, even at such breakneck speeds, it's a long haul from the sun to our home planet. Depending on the speed and intensity of the ejection, this cosmic journey can take anywhere from 1 to 3 days. As the storm cruises through the void of space, its trajectory and speed are influenced by a variety of factors. The solar wind, a stream of charged particles constantly flowing from the sun, can either impede or facilitate the storm's progress. Similarly, the interplanetary magnetic field, a part of the sun's magnetic field carried into space by the solar wind, can alter the storm's course and speed. But what directs these storms towards us? Well, it's all down to the sun's rotation. As the sun spins on its axis, its magnetic field lines become twisted and tangled. When the tension becomes too great, the field lines snap, releasing a burst of energy and sending a solar storm hurtling towards Earth. Once the storm nears our planet, it encounters the Earth's magnetic field, our first line of defense against these solar onslaughts. This interaction can cause beautiful displays of auroras, but that's just the silver lining of a potentially disruptive storm. Once a solar storm reaches Earth, it doesn't knock politely on the door, it barges right in. The real journey of a solar storm begins when it interacts with our planet's magnetosphere, a story of beauty and chaos that we'll delve into in the next segment. When a solar storm hits, it doesn't just light up the sky, it can wreak havoc on our technology-driven world. As the fury of the sun reaches out to us, the first thing we notice is the mesmerizing dance of the auroras. These northern and southern lights, usually confined to the poles, can spread across the globe, casting an ethereal glow that lights up the night in a symphony of colors. But these beautiful spectacles are just the tip of the iceberg. Beneath the surface, solar storms can cause significant disruptions to our power grids. The intense electromagnetic fields generated by these storms can overload electrical systems, causing widespread blackouts and leaving entire cities in darkness. Our communication systems aren't safe either. The radio waves that carry our phone calls, television broadcasts, and internet data can get scrambled, leading to dropped calls and sluggish internet speeds. Satellites, which are crucial for everything from weather forecasting to GPS navigation, can be knocked off course or even completely destroyed. And let's not forget about the risks to human health. Astronauts in space and frequent flyers at high altitudes are exposed to high levels of radiation during solar storms. This can potentially increase their risk of developing cancer. Solar storms, while beautiful to behold, are a force to be reckoned with. So the next time you gaze up at the sky and see the auroras dancing, remember the power that lies behind their beauty. Solar storms are a testament to the sun's immense power and the delicate balance of our space weather system. Born from the sun's turbulent surface, these storms embark on a cosmic journey, carrying with them the potential to disrupt our earthly systems. The impacts are far-reaching, affecting power grids, communications, and even giving us the awe-inspiring spectacle of auroras. So, next time you see an aurora, remember, it's not just a light show, it's a cosmic dance of energy and magnetism.